Most bus, media-oriented systems transport. I hate reading off slides, but there are some important pieces from these next three slides where I talk about most bus. And then I've got two case studies for you. I've got a General Motors case study, and I've got a Jaguar Land Rover case study, which kind of encompasses the two most commonly used type of most bus systems out there. So it's a high-speed multimedia network. They all most bus that I'm aware of are only for information and entertainment, so infotainment systems. Now, basic operation is they are a closed ring. There's not going to be any DLC connection for most bus. The only vehicles that have an external connection for most bus is on BMWs, and there's a most bus connector location for testing on some of their vehicles that take a special adapter for use with ISTA. Now, there is a master node that generates a clock synchronous frame stream, and then everyone receives all of the messages, one after the other, a continuous loop. So it's not a situation where like there's arbitration like there is in most networks. It is where there will be everyone receives every message and it just stays on the bus, and it's kind of everyone's adding their piece all the time. It is a very high-speed bus. But they all receive it all at the same time, one after the other, just in a loop. Now, there are a couple different architectures that are out there. All that I have ever really seen is these three. I don't know if there's another type that could be designed, but that I'm aware of, it's these. There's ring topology, which is just a closed loop where each node forwards data to the next. And then any kind of failure in the connectivity breaks the entire system, unless there's a dual ring topology, which is the same thing, just to skip at the bottom there, is two parallel loops, a primary and a secondary. And most run just a ring topology, a single ring topology. That's what almost all Jaguar Land Rovers, BMWs run. Most of my experience are with Jaguar, Land Rover, BMW, and General Motors for most bus. I don't believe that I've done a diag on a most bus on anything else. A daisy chain topology is a linear series of nodes where each device is connected one after the other, and it's simpler and cheaper, but lacks any kind of fault tolerance. Now, I believe that daisy chain topology still operates. To me, I don't know of any daisy chains that are actually out there. They're all like a ring topology that work in a daisy chain type. There is a in and an out. And depending upon the medium at which they are, which we'll talk about on the next slide, will kind of depend upon their total overall speed, and there's lots of physical restrictions with doing most bus. So there are three different speeds and mediums of network. There's POF, which is plastic optical fiber, which is most 25. That is where most Jaguar, Land Rovers, BMWs will operate in. There's most 50, which is coax style, which is what General Motors has used since 2014 when they introduced most bus, when their new generation, whatever NGI indexing. I can't remember exactly what they referenced in their service information about it, but they use most 50, which is that's coax style, so it's a 50 megabyte per second speed capable. There are probably BMWs and Jaguars that are using POF style connections at most 150 now. I would only assume they are being some of the first to implement it. BMW that they have a most 150 system out there. I don't know. It doesn't really matter, to be honest, because your way you're approaching the system is going to be the same, but it just be the tools and bypass type cables you would use would be slightly different. So failure in any node usually can break the whole ring system. Depends upon the type of failure. Any kind of failure that would prevent or stop communication in general would pretty much create an issue. Whether it be a short or an open, or even lack of communication or power grounds to a module that's within, or to a node that's in that system. I'm going to reference them as a node because all of the data you'll read references them as a node. Now just know that when I say module in a most bus, I mean a node. When I say node, I mean a module. They all require some kind of specialized tool for testing and isolation. I should take that back. They don't require. They call for. When working with the POF styles, you will be required to have some specialized tooling. You can get it relatively inexpensive on Amazon. I keep probably 5 or 6 sets of the most bus isolation ring tools around the shop. For the General Motors ones, there's kits that are sold. They're really hard to find. So if you're looking out on eBay, keep an eye out for them. If you find them, go ahead and purchase them. They're worth it. If not, you can still do them without it on General Motors because they are like they're coax, but they're essentially, most of them are twisted pair wires as well. So they're actual like regular style wires that you can back probe and look at and deal with. So it's not some super exotic situation unless you are dealing with Jaguar, Land Rover, BMW. And then the exoticness of them is because it's fiber optic type cable, plastic optic fiber optic, and they are exotic in design for automobiles, but not in cost. So when you purchase those bypass cables you get off Amazon, they are rather inexpensive. $20-$30 I think is what I paid for the last 2 or 4 pack of them. So very, very easy to get a hold of the tooling for it. Now, because like I spoke about this before, it's clock synchronized ring, so there's no event base. Each module forwards all of the data, puts its piece on there, talks, and it just continually goes around. There's the master module, whatever module is the master node on the network, is going to set that synchronization signal, like the rate at which it talks. And if you remember like an old VCR, it would start tracking the screen. That's because the frame rate of the flashing was at the wrong frame timing of the actual images on the VHS tapes, on the actual film tapes. And that's what would cause that tracking and the lines to move up and down, and because the synchronization was off. So just like that, in a most bus system, the master module does the synchronization, so all of your timing of images are there. Now, what's very different about digital images that must be timed is in the event that you're off, you usually don't get the screen to be physically off. It just doesn't capture any image at all. So if data is being transmitted and clock synchronization is gone because the master module is not communicating or is not on the ring, then you typically will get nothing. You'll get 0. It's like, you got to imagine there's a piece of image and data in there, and it has to be picked up and put down exactly the right time, or you don't see it at all. It's just completely gone. So the cool thing is, because of that, it either works really good or it doesn't work at all. So you'll typically get a 0 judder, 0 audio problems. It's not like it freezes up or any of that stuff. It doesn't create a condition where it's ever low quality because of a most bus problem. The only time you get low quality transmission is when it's junk transmission in. So when your signal capability in is bad, when you've got failed antennas, or the signal, you're just too far away from whatever video source you're digitally getting. If it's satellite radio and there's extreme weather and overcast, you typically just get a loss of transmission altogether. So it just has to be, it's a situation where they put a lot of R&D into this, and MOST is actually a company. MOST is actually a company. So there's some kind of licensing to do with that as well. So that's why a lot of this stuff is very, very different from what you would typically deal with inside of a vehicle. And fiber optic, you're not going to be able to like back probe into. So it's really just a lot of isolation of one circuit to another to determine, okay, is this a module or is it on the physical layer of the network? And if it's physical layer and it's POF, whole entire harnesses have to be replaced. And it's similar with like UTP style and coax. You're gonna have to replace. They don't have very many repair options for those, but you'll see that's what you'll find. So hopefully, most of your issues you will deal with will be much like what I deal with, and they will simply just be failed modules and or open circuits that you can repair. What I can tell you is most of the General Motors vehicles I do this on that have some kind of damaged most bus. If anytime I've dealt with, 3 of them were struck by lightning. Now, this particular 2020 Suburban is not the case. It was not struck by lightning. This was a mobile call from another shop, and unfortunately, we didn't get quite all of the history, but we do have that the radio screen is just black, and it was replaced last week. They replaced the screen in an effort to fix this. Everything was working when they installed it, and then the vehicle set over the weekend, and now the screen's on, but the buttons are not working, and then it intermittently drops in and out. And this vehicle actually took about 3 stops, but I've condensed it into a bit of a case study. What I will tell you is multiple modules did get replaced on this. Once it was all said and done, and we were called back the 3rd time after we had called for a module, installed and programmed the module, and we had a different set of problems now. And it was later determined that a lot of parts were replaced with used ones in an effort to attempt to repair this. So we called for a part and installed it, and then basically at this point, almost every module, HMI, radio, everything, and they were a lot of them were remanned, a lot of them were, some were not programmed. So there were a couple stops. I cut out all the muddiness and just turned it into what it is for the case study for one section of it, of diagnosing the concern. So those are our tech notes we grabbed while we were out at the job. Basically, they actually put it in as a programming. When I showed up, asked them, okay, what am I programming? It says here, radio screen. I hooked up to the car. Radio screen's not a programmable module. It's just a component. I said, perfect. Doesn't need programmed. Would you like me to diagnose it? And they go, oh, we just thought it needed programmed. Yeah. Okay, so here's the story. And then they go to proceed to tell me the story. I'm like, okay. So as always, I try to start with a diagnostic scan. I used both the GDS2 and the Autel in this case study. So this pre-scan is from GDS2, because I was there with the laptop already hooked up to program a module. And when I got done, or as soon as I determined, wait, this isn't the module it needs programmed, it's, a diag, I went ahead and grabbed my pre-scan with this, and the rest of the diagnostic was done with an Autel. So it doesn't require an OEM tool to do this job by any means. Okay? So looking at the scan, there's a large number of modules with loss of communication codes, but we're going to kind of focus in on these 2 radio codes, U0028, U0029. So U0029 7F, when presented alone with no other DTCs, no other U code DTCs, or not with a U0028, would typically suggest an intermittent fault. But a U0028 typically sets when, and a U0029 is almost never a physical layer problem. It's always some kind of module or something. But a U0028 can be a physical problem. The most bus fault itself is just a generic U0028 semicolon 00 with a 00 byte. When we go look at that data and we look at service info, it starts out with, here's a chart of all the things that could cause it. So, a short to ground on the B+, an open or high resistance on the B+ to the module. A short to ground or a high resistance or open to the ignition circuit could cause that. To the most control circuit, there could be an open or high resistance. To the most serial data, plus and minus is a TX RX system, so it's semi like a dual ring fault tolerance to some degree. Because there's one transmit down the network and one receive back. So an open on one leg, the whole network would at least be able to receive diagnostic data back. If there was a short to ground and open, or a short to voltage on either one of those 2, it could set that code, or an open or high resistance to ground. Now keep in mind, the only other things it was talking about is the most control being short to ground or short to voltage would have to be like a U2098. If you go look, there's actually a U029802 here. Most communication enable circuit. So there's the enable circuit as well that has a fault on this car, although not highlighted. So what I want to point out is that this U0028 dang near could be any kind of fault with the most bus itself, whether it be on the control side or on the actual serial data side. So the thing to think about on this one and how it's designed, we're going to break out some architecture information, look at some more scan data. I want to talk a little bit about how the system works. So the radio is the diagnostic master and is defaulted as node number 1 in scan data. There are conditions when there's a fault that the node number shifts to node 0. Now that's kind of confusing, so just give me a minute and we'll get there. Okay, I'll draw some pictures for you. So every device on the network provides 12 volt B plus on the most control circuit side. Now the radio will pull that 12 volts to 0 for 100 milliseconds, and that signals all the nodes on the network to wake up. They're all like, hey, they all see it pull to ground, and that tells them all to wake up. So if modules are not turning on, but the most serial data bus physical network is good, that pull to ground would create the turn on signal. And that's why a short to ground on that side, on the most control, couldn't really cause the most control network to set this DTC, and neither could a short to voltage, because either of those states are normal states for that control circuit. But an open in that circuit would cause, or a high resistance where it wouldn't quite get 12 or it wouldn't quite get 0. Either or of that could cause that. That's why when you look at that, most control can only happen if there's an open or high resistance to cause a U0028, and you'll notice U2098 is for the other options, is because the most control is either a 0 or a 12. Although it's only designed to be held for 100 milliseconds, modules don't exactly count like you think that they count. There's a hysteresis layer of pull down and time frame before that starts. Now, when the most ring is incomplete, the radio is going to send the 0 volt pull down wake up message every 2.5 seconds. So every 2.5 seconds, there'll be a pull down, and you'll see it if you scope that most control wire. Also, it lasts for about 0.3 of a second. So they're pretty good little 3 to 4 tenths. I think at the service info states 4, but I think I've read before in another car where it was 3 and most designates 3. So it could be a typo, or it could be that GM has some kind of other control tactic on that. Now, we're going to use data stream for a lot of this. So we're going to look at data stream, look at network configuration, and then do our testing on the car. So my first interactions with most bus on General Motors vehicles were rather testing, because I didn't quite understand it. I didn't take the time to go learn it like I should. So I'm going to show you a couple tricks that make it kind of easy. So the first thing that I typically do after I pull the DTCs and realize there is a most problem is I'm going to go to the master most module, which is the radio on this vehicle, and I'm going to pull the live data stream from it and take a look. Now, this first number, the number of most communication breaks, is the amount of times the radio sent the wake-up signal without receiving it back from every module. And then from there, we have last working most ID of node 1. So under 99% of circumstances, on General Motors, the radio is the master node, and it will be at radio master node number 1. There's also another data PID of node 0 that can also be radio, depending upon where the fault is, how the node numbers will shift. So basically, radio says, I'm node 1, who's next in line? And then the next module should respond back over the TX. It receives the data over the RX. It receives back on the TX. Hey, I'm the whatever, I'm node number 2, and then so on and so forth. So you can see in this particular piece of screenshot, there is the last working most node ID of number 1 was radio, and the last working mode ID of number 2 was unrecognized state, and then that for the rest of the nodes. Now, we don't quite know how many nodes are left on this vehicle, and there's no surrogate master node upstream position listed, which means it's only one module talks. In the event the radio doesn't communicate, another module can become a surrogate master node, and it will recognize itself as a node position. And we need to know its physical position as well as its digital position, because you can have where most node number 2 shows a module that is not the second one in line, depending upon the type of failure you have, and whether it be a power ground failure to the physical node number 2, or it be a break in the TX or RX circuit, or a short. Now, that pattern basically continues down the line with each module. All right, so if we move on to looking at a diagram of this 2020 Suburban, Like, all right, we need to, now we know radio only talks, next one in line doesn't, or nothing responds back. We need to know what the network looks like. So node 1 at the top there, the A11, is the radio. Just kind of circle that up there. Node 2 question mark is the CD player, the media disc player. Node 3 is the human machine interface module, the HMI. Node 4 question mark is the audio amplifier. And node 5 question mark is the instrument cluster. Well, it probably has an instrument cluster, but whether it's on the most bus network depends upon the type of infotainment system it has. So there are three distinctive sets of RPOs for this vehicle that it could be. So we need to investigate which RPOs this vehicle has, because it may not actually have a CD player. It may not have TG5 or U42 and bypass that altogether. And then it's got a human machine interface, and then it goes to node 4, which is an amplifier. Then based on it having UQH, UQ Alpha, or UQS, Uniform Quebec Sierra, it could bypass node 4, the possible node 4, the amplifier, and move on. And then same thing with the instrument cluster. Now you're thinking, Keith, they didn't make a Chevy with no instrument cluster. You're right. But they make Chevys that have instrument clusters that are not on the most bus because they are a lower option package truck. Why would an instrument cluster be on the infotainment system? Well, that involves your cell phone and that communication. And when you press that button, when you look on your cluster, it tells you who you're talking to, it tells you that it rings in, all those things. So that could be part of the most bus. The instrument cluster is a feedback. It shows you. So there is some imagery on it. All that data has to be received over something. Now, yeah, it could have been bus from the radio over high speed, but it isn't in these General Motors systems. This is how they design them. So, if we take a look and go to repairlinkshop.com. Now, this is free. You can make a free account with repairlinkshop.com. You will have to go into this My Dealers section, find a General Motors dealer around you, add them to your dealers. And this is for you to be able to just order parts, but it's great to just look up part numbers and look up VIN-specific data. So an instance, like Jaguar Land Rover, the Jaguar of Tulsa is not on RepairLink Shop. So I added the one that's in Plano, Texas. And I did that so I can go on RepairLink Shop, put a VIN in, pull up electrical, pull up what I need to, find a part number that I can call Jaguar Land Rover of Tulsa and be like, hey, is this part number available? And then also, sometimes you can call that dealer, like let's say the one in Plano. I've called them before on parts and asked them, hey, this says this much. What would you charge me to ship it to me? Because the cost was significantly cheaper than the local dealer. So go to repairlinkshop.com, make an account. It's 100% free. Set up your dealers for each of the brands you deal with. And then you can use, at the very least, set up the General Motors dealer. It's easier to order parts from them, and you get discounts on the parts over what they give you in store. And then you've got this VIN attributes button. So after you've made your account, added a dealer, click up here on VIN, put your VIN in, press search. It'll pull up this page immediately. You'll click VIN attributes, and then it's going to give you a list of all the VIN attributes. So on this particular vehicle, we do have TG5, but we do not have U42. We do have UDD for Display Info Driver Infotainment Center, the enhanced version, the multicolor graphic. And we do not have UQH, UQ Alpha, or UQ Sierra at all. So there's no UQ, AH, or Sierra for this particular vehicle. So it says UQ3 for Enhanced System Performance Speaker. So the UQs are probably some kind of audio specific system. So when looking at this with that data, that means we do not have an amplifier on this vehicle, but we do have the CD player and the instrument cluster as part of the most bus. So we have 4 nodes on this vehicle. Node 1's radio, node 2 physically is the CD, node 3 physically is HMI, and node 4 is the instrument cluster. So now we have quite a bit of information. We know we're not dealing with an amplifier problem. It doesn't even have that. I want you to also notice that I didn't call out in this particularly, but X225 is the only two that go around this. That means it would go out to an amplifier and come back, and there's a lot of that on these vehicles. So there's not many connectors anywhere else on this system, as you can see, and it is a twisted pair of wires that is the TXRX. You'll also notice the node master indicates the direction of travel. That's how I know that node 2 is media display or not instrument cluster. It is indicated on the modules the direction of communication flow traffic. You'll see the arrows point down. So it was very important that we get accurate information about this vehicle so we know which direction to test. So we're not too terribly far right now into the actual diag, but we do have quite a bit of information. We know what it's not immediately. We also know that only the radio talks and CD player isn't. So we probably have, because it's multiple nodes that are all down, I doubt it's a power ground issue. It's more likely that it's a physical network layer issue. And if that's the case, redrawing the diagram here just to get a better visual representation, our 3 modules not talking and the one that does means we most likely have a failure that is physical in nature in this particular connection. So we're going to look at this and go, okay, node 1 radio talks, the rest of these don't because the rest of them say unrecognized state. That's how we're grabbing that data. If we look at that wiring diagram, we get to the back of the radio assembly and we go to actually check the connection, we can see every about 2.5 seconds, I got 2 seconds per division on the U-scope here, about every 2.5 seconds we get a pull down from a 12-volt signal. Well, the radio is outputting 12 volts and the radio is pulling to ground to wake up all of the modules. Now this is measured directly at the radio. So knowing that our fault isn't directly there, that it has the B plus that we expect to see it, and the pull down from the radio, we know that, okay, we need to move on closer to the CD player, the next in line, because this obviously isn't the issue. The radio integrity is there, and I've had failed radios this way before. So taking a look at the notes here of what it did. So bypass the cluster in the human-machine interface one at a time. It did not fix the network because I believed, okay, if there's a complete connector disconnected or something, because people have been in here, and I don't know what the original issue is. The problem is this place is a used car dealer, so it's hard to get why it was originally dealt with and what all the history is. So I accessed the CD player to bypass it, and I had to remove the upper cover to the CD player assembly, and when I pulled upper cover off that was around the CD player area, most bus communication came back. So wiggling the connector at the CD player, I got like some different changes in it. The radio stations would change on its own. Audio would come back and go away. So definitely I'm messing with the most network by doing this. So when I pulled the connections and just retensioned the pins, because looking at them, they all looked pretty fine, and then put them back, it looks like I fixed the problem. So it was terminal fretting. It was due to a poor or bad connection at the CD player. So I told him, and this is the notes I wrote in there, if the problem comes back, I'll need more time to continue testing. The reason it was written this way was because multiple other repairs have been done to this, and I believe that this was a problem that was induced due to a testing method someone used by front probing a connector. Now, looking at this, when I got done, this is just a post scan down here. I just had loss of comm with electronic brake control module or invalid data and then tire pressure monitoring system. These were faults to be addressed otherwise of the radio system. This was a pretty basic diag of a most bus, but if you weren't aware of how the node system operates, it could be pretty difficult to pick a starting point in knowing what does and does not communicate, right? You've got a sealed system that you can talk to one single module of the radio. The rest of them you can't really, the rest of them are actually, what's funny is on a LIN bus or on a GM low-speed LAN as well, but you don't quite get the information about the most bus system until you look at the data in the most node master, which is the radio. So that process of just understand how the system's designed, what does the architecture look like based on RPOs, what do we have and not have, okay, we can talk to this and this, looks like our communication break has got to be at this one spot. We were able to reduce a lot of manual testing time down to, well, it's got to be between here and here. just on how the system was designed. So as much as a most bus network is a little bit, they're a little bit less fault tolerant than what we would want them to be. They seem to have issues within General Motors and BMW environments. They do operate well, and there's plenty of data to diagnose them without a bunch of manual testing like most networks. No pun intended there. Like many other networks, there is quite a bit of diagnostic data built into the scan tool part of a most network. All right, let's move to a 2012 Land Rover Range Rover. Customer states most of the electronics on the dash are inoperative. Please diagnose and advise. This is a kind of an older case. This is kind of an older case study for me. But the guy's last name is Mills, Mr. Mills. He brought this to me, and it was a bit of a challenge as there were multiple faults in this system as well. So we've got a scan of the vehicle, and everything's talking except for the audio amplifier module and the parking aid module. Now, they're both, again, I was called to program. They had replaced an amplifier with a used unit, wanted me to program it, brought the vehicle to me, attempted to program it, failed the programming, went on from, okay, do you want me to diagnose this? So I already had some data like here, again, where I scanned it. I get a lot of these start with, hey, I've installed a module or whatever. And that's what this one was. Customer installed his own module, and that's what we got to work with here, unfortunately. So I said, hey, that module is actually, not programmable because I can't talk to it. So we're going to have to fix that first, right? So looking at a scan of the vehicle, lost comm with parking assist and lost communication with audio unit. Now, what does the parking aid module and a audio amplifier module have in common on this vehicle? I want you to think about this. Well, they have a physical location that they share. They're bolted to each other with a few other modules in the rear driver side panel of this vehicle, where these vehicles are notorious for one fault: water. And these modules both had water damage inside of them. Funny thing was this is a amplifier out of a different car. Okay, so I said, hey, look, you may have diagnosed it right. I'm not sure, Mr. Mills, but we're going to have to replace this amplifier again. We're going to put a new unit in it this time, and the parking aid module needs to be replaced as well. Now, Mr. Mills declined the parking aid module repair, wanted to just fix the radio because the radio doesn't work at all. He doesn't use the backup sensor stuff. So I said, okay, we will get a new module, install it, and program it for X dollars. He said, okay. Got the replacement module in and got it programmed. And it was able to be programmed successfully. Now, once the audio amplifier was replaced and programmed, we had a replacement radio screen that was blank. So, or not replacement, but after the audio amplifier was replaced, the radio screen is blank. So looking at the DTCs, we actually had a most bus network, and that's by default. If you turn the key on and the power button on the radio screen blinks at you, you have an open in the most bus, and you have to go tracking that down. So this is the network. Shows, instrument cluster, tuner, amplifier, touchscreen, integrated audio module. And I don't know which one's the most bus on this car, or most bus master on this vehicle. I believe it was the integrated audio module, but it doesn't actually matter. There's an open somewhere we're going to have to utilize. Now, the good and or bad thing is that this vehicle, being a Land Rover Range Rover, they're fiber optic, so there is no repairing these cables easily, and they don't get damaged super easily either. So when we go to look at this network, all right, well, we just need to figure out where a fault is and see if there's an issue. Now, I usually start by trying to bypass these modules at the modules. That is by far the simplest thing to test, and you can get different behaviors based on how you bypass them. So pulling down the integrated audio unit, this is the actual radio module here on the right hand side. bypassed it, you're able to disconnect, and you can see here, this is what it looks like when you disconnect and connect a bypass unit. But then the bypass cable you see here there's an audio tuner back here. So the AAM, the amplifier is here on the floor. You can't really see it. The parking aid module, I believe, is that unit. Yeah, is that unit that's black with the 2 tan connectors and 1 black connector right there that Mr. Mills decided to decline the repair on, which is perfectly fine. It wasn't associated. I totally understand that. Let's figure out what's going to cost to fix the radio before we go on. So at this point, we don't know if the original concern of the radio being wet was a problem at all, because the radio that was installed in it was used when he got online. It was faulty, needed to be replaced, and then we still had a blinking radio screen. So the conversation was had with Mr. Mills about what was the original fault, and he said this blinking radio screen. Okay. So it's very possible we didn't repair this. Well, all we did was undone what was done already, since he didn't have the original amplifier. So, looking at this, we've got the radio tuner unplugged and bypassed. And when we do that, this is what we got. You guys should be able to hear that. Yep. Some Red Hot Chili Peppers. So once the satellite tuner was bypassed, the system worked as designed. Screen came on, everything was good. So we had a multiple module situation at the rear of the vehicle. It was faulty. So multiple as in the customer replaced the amplifier and it was faulty. We were able to find the satellite tuner was faulty. Oh, sorry. I'll bypass that. Don't want to listen to Red Hot Chili Peppers. I would love to listen to Red Hot Chili Peppers some more, but moving on. So, when we get to communication faults, comms are just voltage, unless it's most bus. Wires are just wires, unless it's fiber optic and it's light, of course. And the biggest part here to leverage is understanding the network architecture and wiring diagrams. Also, documenting every single thing you do is super powerful. You got to remember, like, most of these vehicles that we've touched, someone else has messed with. So I need to go back and prove to my client that I am not the one that created these other issues. And especially when you're like, oh, we need this part. You put that part in it, it doesn't fix the whole car, but it changes the DTCs, it changes the behavior of the problems. The documentation is so important in proving that you're not throwing parts at stuff. I hate it when clients bring me vehicles and they go, well, we've already done this, and this. We tell them right off the top, hey, unfortunately, most of the time that multiple parts have been replaced, we have to replace more parts. And so I just tell them the average repair cost of a vehicle that nobody else has looked at is about $400 for a single problem. In the event that somebody else has attempted to fix it, what we have found is the average repair cost is at least double. It's around $900 and some change. And that's just stats from our shop, just repair cost on single issues. So what we find often is just like this, where, yeah, we had to do an amplifier, but that didn't fix it because all that was repairing a faulty component someone else installed in error that wasn't the original problem. We don't know. It might have been the original problem as well. Both those are back there. His original one could have also been wet and had a problem. Maybe it had multiple problems. But the water leaks needed to be fixed in that car. Same thing with the Chevy. Not sure what happened. I left it out there, but most of the connectors were also like covered in dielectric grease. Somebody had been in there. We've had those problems. That unfortunately is a situation that we deal with. So create a process that deals with understanding with the network. Create a process that has to do with a methodical documentation of what you're doing, and then use the process, of course. All right, guys, that is the last slide of the network class.